So now we're going to get a formula for the number of permutations, or R permutations, of n things and distinct things. And the formula, let me make this a little smaller so we capture it all. The formula is PNR is equal to n times n minus 1 all the way through n minus r plus 1, except in the case when n and r are both 0, and that will simply be equal to 1. And I might make a comment about that case, but we'll really start by looking at the original case. So here we're talking about how many ways can you create an R string, basically, of n distinct things without repetition. So this is really the same as, and I'll go ahead and say it this way, the number of strings, length R, of n things and distinct things without repetition. So we want to take R of the things and order them, but we can count this by looking at slot argument. So the first thing, we're going to choose R of them in order. There are n choices. For the second thing, because it's without repetition, there are n minus 1 choices, and so forth on down to, for the rth one, we want to choose R of them. We've chosen R minus 1, so n minus R minus 1 remain. That's an n. So that's n minus, well, remove the parentheses, that's n minus R plus 1. So it's that product, which must be P and R. So that shows it. That's the expression for that right there. So why do we do this right here? Why do we say P00 is equal to 1? That says how many ways can you form a string of 0 things chosen from 0 things? Well, there's one way to do that, and let me show it to you. Okay, I'm going to show it to you right here. There it is. Nothing. The empty permutation, or the empty string. But that's really the best way to do this so that it fits with everything else we're doing. There's one way to write down an empty string. Yep, you can't make that look different any way you do it. Okay, so let's use factorial notation on that same formula above and see if we can write that in a factorial. So I'm going to write this down here below. So I'll write PNR. I'll get that tail off of there and write that a little better. NR is equal to n times n minus 1 through n minus r plus 1. And now that I have copied that, I'm going to go scroll this up a little bit. So that is the same thing as completing the factorial. So we have all the integers from n stepping down one at a time until we get n minus r plus 1. So the next one from here would, the next smaller one, subtract 1 to get the next smaller one, that's n minus r, down to 1. And down on the bottom here, let's divide by the very thing I multiplied by, n minus r minus 1, dot, 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 1. So I chose to do this by multiplying by this and dividing by the self-same thing. So I haven't changed it, but it's convenient because now the top looks like n factorial and the bottom looks like n minus r factorial. So that's an expression for this. This is n factorial over n minus r factorial. That is the number of r permutations of n things, the number, if you like, of r strings, or strings of length r, chosen from among n distinct things without repetition. We have time to do a few examples here probably, And we could have already done these examples, but what I want to do is put them in the context of permutations. So the first one is like a skating competition. The top 3 skaters in a competition will be awarded the gold, silver, and bronze medals for first, second, and third highest scores. So the question is, how many different ways are there for the medals to be awarded if there are 12 finalists entering the competition? So basically what we're going to do is take 3 of the 12 skaters and put them in order because of the difference in the medals. Put them in first, second, and third position for the 3 medals among the 12. So this would really be P, 12 distinct things, choose 3 of them. That is the number of 3 permutations of 12 things. Okay, so that's 12 times 11 times 10. You know, that's the same thing as saying, okay, there's the number for gold, then this is the number for silver that are left, the number of choices for silver among the remaining ones, and finally there are 10 remaining to choose from to get the bronze. So I've done it in 2 different ways there, you know, described it first as a permutation, 3 permutations, and second by using our typical slot argument. So this next one is similar to one that we've done before by saying how many strings of 2 letters are there from the letters A, B, C, D, E, F, G if the letters are not repeated, right? So a string would normally allow repetition, but I'm saying, okay, a string now without repetition. Well, this is just the permutation of, there are 7 things here, and we're going to take them 2 at a time. We're going to form the 2 permutations of 7 things, and that's equal to 7 times 6, like so. In fact, there are 7 choices for the first one and 6 for the next one, since it's without repetition. So here it's easy enough to multiply. I'll just say that's 42. There are more examples we'll do, and we'll talk about combinations as well, in contrast to this notion of permutation in subsequent videos.